Okay. Yeah, I just realized that I have this workshop. So I just do one that I do regularly, actually. So the thing is, when we develop some smart contracts, and we can do that together, it's hard to get the data out, especially at the hackathon. So at the hackathon, you probably at some point, you have like a contract. So let's take ERC 721. Oh no. And then we make it, that's actually okay, mintable maybe. And yes. And now I have a token here, and I want to publish that token. Maybe we can do that everybody can mint, actually. That's more fun. And then we can just simply deploy that token to, I'm here on Sepolia, right? So we can just deploy that contract to Sepolia. Let's do this. While we're waiting, we can also, in the background, I think somehow, let's see. I thought like Sepolia is faster. I think we need to have the flattener installed. So there's the flattener plugin. Oh, it's not existing anymore. Okay, so we have it now deployed. So we have like a contract that's created here. We see that, right? And now we can go here and verify that contract. I think it works through. Yeah, I have the key here. And now how do I verify? It's been a while now. Here. It's been a while. Anyways, I can just go with the ABI, actually. Okay. There is always like multiple paths to the goal. So, but we have a contract deployed. Let's quickly mint the token. So we also have a token, so we can have a save mint, address to, I save to myself, I mint to myself, and token ID, let's do 0, and then just send this quickly. So we have some data on there. Cool. While we're waiting, the next step would be to simply have a subgraph that now tracks these transfers. So we can go here and go to the graph.com/studio. There's scheduled maintenance coming up. Maybe we can do this a little bit smaller. And I can just simply create a subgraph and say like ETHDam. We index Sepolia. Where is it? Here. Then create the subgraph. Nice. And then we can just follow these steps here on the right. I already installed the Graph CLI. So what I do now is I just do graph init studio ETHDam. Before we do that, I need to download the ABI actually here. So I have the ABI to the clipboard. I can just quickly do JSON, just paste it. That's it. And now we have the ABI. And I can start with graph init, go here, and just follow these steps. So the first question is like, which chain do you want to index? So it's Ethereum. Then the subgraph slug, we can just take what is recommended. So it's ETHDam. Then the directory, I would say we could just also go with the default one. Then here we need to check the chain again. So it's Sepolia. See, these are all the chains that are supported on the graph. Now we can use Sepolia. And the contract address, I have it here, right, just deployed. So I can copy paste that address or copy and then paste. So the ABI is not found because the contract was not verified on Etherscan, but because I just downloaded it and created, I can just get that ABI.json here. Then we need to set the start block. The start block is at the block at the transaction for the contract creation. So I can just quickly get that number, paste, and let's give it the name. So it's ETHDam. And then here is where the magic happens. Like we can index the contract events as entities that automatically generates a subgraph that has all these entities indexed. We will see that in a second. Here we see on the contract already that we have two transactions. Like one is the contract creation, one is the first mint. Now we need to wait for the dependency to be installed, but like we can, in the background, we can just quickly look at the code. Maybe it's done. I know that error. Dependencies always break, I don't know why. But we can look at the code. I can make it a little bit bigger, I think. Yeah, it's different here than on the others. Zoom in. Cool. So a subgraph basically consists, I first always look at the YAML, that's kind of the subgraph manifest. In the manifest we see like which is the address that we want to index, what's the name of the ABI. The ABI then is found here. It's copied over the start block as we just defined in the terminal. And then we have here auto-generated for each event, we have a handler. So we know like on an NFT contract, we have approval for all, ownership, and transfer. But transfers are actually the ones that are the most interesting for NFTs. And then we have a schema. We see also the schema is referenced here. So the manifest actually keeps everything together. The schema is here. We have the schema is basically a database schema. It just defines how the tables in the subgraph, the shape of them, and each of them is also automatically generated. So we have like an ID, and then for transfer we have a from address, a to address, we have a token ID, a block number, a block timestamp, and a transaction hash. So we can go into the mappings, and then we see, for example, a handle transfer. How this looks. So we receive the event, and then it's all generated for us. We just create a new entity. We set these fields on the table, and then we save it. So the code here that we see, it's written in assembly script and not TypeScript. That looks very similar, but it is slightly different. But the cool thing is that we can also explore what's going on here. So we can jump into these definitions. But first, I need to do the code gen. Yes, perfect timing. So we can do yarn code gen, which generates the code for me. So like with code gen, what it does, it looks at the schema and it looks at the ABI, and here writes some generated code. That's cool so we can see like how these objects are created, and we can explore them and see what other data we could actually add into the mappings. Cool. So, but we don't need to actually change anything here, because like already by having a subgraph indexing the events with this auto-generated one, we have already very cool stuff. So we can just authenticate here with graph auth. And then we did that code gen step, and then we can just do graph deploy. We need to give a version label. We follow here the semver. And boom, the subgraph is deployed. Now we see here it starts to index. It's already at 100% because I mean like the block is not that long ago. And now we can go into the playground. And with the playground, it's important that we can go here to the GraphQL Explorer. And here we can explore all things that we can query with GraphQL. So it's very cool. We can look into how other subgraphs look like. So we can open the transfers, for example, and see the block number, timestamp, and just select all these fields that we stored in the database. And now I can send that query, and boom, I have everything here. So Now we have a contract, and we don't need to mess around with JSON RPC, getting that data out from the contract or anything. We just can use this very nice GraphQL interface. We have here a development query URL that I can put into my front end and send these queries, and makes it much easier. And maybe just to make sure that I'm not joking here, so I can do a save mint again. So let's say I mint myself the token ID 2. So I sent this, confirm. Let's wait on EtherScan until it is picked up. Okay, so they say they have it. Maybe the graph already has it too. Let's check. We can go again here. Transfers. Send. Boom. We see we have 2 transfers already on that contract. Now the beautiful thing is, like, we have now a quick start. We have like a GraphQL interface to our events. So we can very quickly start to program. But like at some point, we probably want to start to extend. So we want to have like maybe different entities. So for example, now we see we only have the transfer events, but I might want to have like an account entity that keeps track of the addresses and which NFTs that they have. This would be the next steps. But I'm jumping back. So for those that are interested in doing this, here is the QR code that links to a GitHub repo where we see we can download the code. It's and there is also like a link to a presentation. There is a cheat sheet. But what I wanted to do is, like, in the first 10 minutes of that talk, to just like remove the fear of using that new technology, because basically if you know what to do, it's like 4 steps, and we already have like this powerful GraphQL API. So that's very cool. But behind the scenes, I quickly want to explain like what happened here. What was this? So we can start with the idea of what is a smart contract and what is the problem. So with a smart contract, basically we have just storage, and the smart contract we talk about the current state. So the smart contract knows who owns which NFT currently, right? But the smart contract directly, there is no call to the smart contract to ask who owned it before. This is hidden in transactions on the blockchain, but a contract basically knows about its current state and not necessarily about its historical state. But that's very important, especially for NFTs. We want to see the value of an NFT actually is who owned it before and how much was paid. So like just knowing who owns it now is not good enough. So we need to have like more data, and also historic data. So when we go back to the same example with the CryptoPunks smart contract, like what the graph basically does is like it's a time machine for that data. So it keeps track of how did the data develop over time. And when we send a transaction to the blockchain, then a new block will create, or the transaction will be in the block, and it's like always one on top of each other. But there's also a problem with that setup, because initially we thought about like, okay, we want to have this fully decentralized future. So everybody can download frontends via IPFS, kind of in a trustless way, and runs a blockchain node on its own computer, and then so we have like really these unstoppable apps. That was the original idea. Zola, you probably remember this what was it? The Mist browser, right? Yeah, the Mist browser was set up like this. Yeah, but then we came away. Like the problem is now how it developed forward, and we have like now the blockchain is very write optimized and incentivized database. It's also append only, and we pay to write to the blockchain with gas fees, right? And so that the validators include the block. But reading data from the blockchain is an unsolved problem, because or are not in the protocol, so to say. So it's very hard. Like the JSON RPC interface to get data out of the blockchain is not optimized to get fast data out, and it's not optimized to actually be used in a front end. It's a very low level a thing that I tried to explain it with when I maybe connect to my home router. Then with JSON RPC, I maybe send some commands to set it up, but it's not like a protocol to actually extract data in bulk. So people end up with JavaScript code like this, like all these awaits things, and all of these are like queries to the JSON RPC endpoint, and all of these can take maybe 200 and 300 milliseconds, depend on the RPC provider. And what the code does is just simply displays all the NFTs that someone holds, right? And yeah, and because of this async nature, if someone has 10 or 20 NFTs, like such a page takes several seconds to load, and that's just like unacceptable wait time in terms of modern UXs. And so, like, that's where the graph actually comes in. You know, sitting in between the blockchain and the user interface, or like the consumer, it could also be like a data science or like a data science application that gets some data and wants to do some calculations on top of it, is the indexing protocol. And we see now with the green arrows, and now we have like an incentivization mechanism, which is the graph protocol. So like indexers are incentivized to index that data with indexing rewards, but also the users pay a little bit per query to the indexer, so that they also have an incentive to serve that data. And now we have like a proper incentivization mechanism to also have data indexed and published. And then we can end up with this beautiful GraphQL query like this to just get all the requests, NFTs from a user, and usually such a request resolves in 100, 200 milliseconds and not like several seconds. Yeah, so that is the graph. We say like APIs for a vibrant decentralized future. On the hosted service, which was built as a proof of concept, we currently have like 1 to 2 billion queries per day. Big names like Uniswap, Audius, MStable, Enzyme, and others are using the graph. Some of them are using the decentralized network also. So it's basically really a fundamental part of the professional dApp stack, I would say. And not only there's this hosted service, but also like there's really this decentralized indexing network protocol, really the vision of saying like, hey, data needs to be public, it needs to be, it couldn't be in silos that like a centralized company tries to also build a business model on top of it and extract value from the user. It really should be like a network, it should be a public good, it should be owned by us all. And so we have this decentralized graph network. There are like more than 200, like actually now it's 440 indexers worldwide. These are individual entities that are run graph nodes or run an indexer for us to serve that queries. And that also gives like this redundancy across the globe. Like when we publish a subgraph to the decentralized network, usually 10 to 15 indexers start to index that subgraph. And when one indexer goes down, then another one is there to jump in. And that gives us a very fast and cheap and reliable option for our data needs. And that's also we going towards this global open API. And that actually enables to build these truly decentralized apps. Like, you know, the D in depth is for decentralized, and now we actually can do it again. I quickly showed you the subgraph. Like I said before, there is the manifest that holds everything together. Then there is the database schema, which just defines the database shape, and then the mappings, which extract data from the blockchain and store it into that database. And others, like I said before, like we always send transactions to the network and they're all laid on top of each other. But for a protocol like Ethereum, we have a lot of different protocols interacting, and that kind of gives this mess of transactions that are all stored in the same store. And what subgraphs do is actually bring them together. So we have like one database for each protocol, and that actually is a function of organizing data, and subgraph developers basically organize the data on the blockchain. And this is roughly how it works. We have the dApp on the top, sends transactions to the smart contracts, get indexed by the graph node, and then on the other hand side, the graph node serves these queries through a GraphQL API. Or in this nice GIF, we see that's what subgraphs do, is taking that mess of transactions and magically bring them into in order. So now for the marketing side, I need this slide. So when you want to tweet about that, you learned about subgraph development. Now is your time. Okay, I see that nobody wants to do it. It's okay. I wouldn't. Oh, do you want? Okay. I would say like I have 10 seconds left. This is just a repetition, but I'll just go quickly through the slides to say you these slides are linked in the GitHub also, so you can read them by yourself. I just want to go to my last slide because it's then the thank you should be. Where is it? Here. Nice. Okay. Do you have time for questions or? Okay. Any questions? Yeah?
Just a simple one. You're talking about database, but it's not a database, it's a table. Actually, at the lower layer of the GraphQL.
Yes, I mean, in the indexers, yes, they run a Postgres database.
Yes. And
correctly you said, so in the schema here, we define tables. Yeah.
Okay, thank you.
And the subgraph, yeah, you mean like the image that I had? Yeah. Yeah, it's a database image, but it's all in the same database technically. But one subgraph consists of multiple tables. Cool. Thank you so much for attending this talk, and have fun.